Okay, happy Monday. We're writing piecewise functions from 15.1. Remember, this is the homework assignment that we worked on. I showed you one strategy for how to write the piecewise functions and it didn't go very well, so I came up with a way to do it on the calculator, and so we're having more success with that. So let's get started. Okay, so remember, a piecewise function means that when we look through this data, we notice that, okay, it's counting by threes in our f of x, but then it stops following that pattern and, it counts by something else. So here it's counting by 12s, and then here it's counting by 6s. So we can tell this is a piecewise function because our pattern is not consistent. So what a piecewise function looks like is f of x equals, and then a bracket, because we're going to write more than one equation to go with this data. And we're going to say when our data changes. When did our equation change from one to the next? So the first thing we're going to do is look at the data and determine where the change happens. Okay, so 0, 0, okay, we're counting by threes, counting by threes, counting by threes, counting by threes, stay the same. So go back to the level where we were still counting by threes, so that's right here. Okay, that's an important area to highlight or circle. It marks the borderline between two pieces of the function. And, okay, stay to 12, stay to 12. Oh, we went back to, now we're counting by sixes. Okay, so go back to this 12 and highlight it. So this shows that we have 1, 2, 3 pieces. Okay, this set of data, this set of data, and this set of data. What we're going to do is, instead of figuring out the equations by hand, we're going to use linear regression on our calculator. So we don't need diagnostics on because we're not looking at R value. We're doing linear regression. So we're going to hit the stat key, edit, and now we're not going to put all the data in the calculator at the same time, because remember how we said there's 3 pieces. The data behaves differently from here to here than it does from here to here and from here to here. So we're going to put this in pieces. So we're going to start at 0 and we're going to enter all of this data in the X column into our L1. Okay, so that's 0, 2, 4, 6, and 8. And the highlighted row should always be the beginning and ending. Okay, so it's going to be the ending this time. Now we're going to put in 0, 3, 6, 9, and 12. Now before we go on, double check 0, 2, 4, 6, 8. Good. Okay. 0, 3, 6, 9, 12. Because remember, if we enter data wrong in these columns, and it's really easy to make a typo, it won't give us correct answers. Okay. So then we're going to go to stat again. And we want it to calculate for us. So we're going to calculate the linear regression, choice 4. You can just hit the 4. And sometimes the calculator has to go through this screen where we arrow down to the word calculate and hit enter, and sometimes it skips it. Just depends on the calculator. So this gives me the format of y equals mx plus b. They use a instead of m, but it means the same thing. 1.5 is what we're subbing in for a, and 0 is what we're subbing in for b. And that's our first equation. The interval I used was all the x values from 0 to 8. So that's the interval. They both get equal bars. Let's finish all the intervals while we're here. Okay, so the next interval is from 8 to 12. Now we already have an equal bar with this 8, and every new interval picks up where the other one left off. So this ended with 8, it picks up at 8, but no equal bar because the this already had an equal bar. This 8 did. So the 12 gets 1. The next interval picks up at 12 and goes to 18. And again, no equal bar here because this one already has one. 18 is the last number. Basically, every number, 0, 8, 12, and 18, 0, 8, 12, and 18. They all have to have equal bars, but the ones where 8 and 12 were used again to start the next interval, they don't get the equal bar. Okay, so we have the intervals. Let's go back to doing the equations. So the next interval is 8 to 12. So I will go back to my stat, go back to my edit, and I'm going to delete these out. You can overwrite them too, but I'm going to delete them out. And you don't have to do this part on the calculator, actually, because f of x, no matter what x is, I always get 12. It doesn't even matter what happens. Okay, so the answer here is 12. So anytime you have the same number, it's just 12 all the time. You don't have to do this part on the calculator, but I will show you what happens if you decide to do it anyway. 8, 10, 12, 12, 12, 12. So stat, calc, linear regression, and calculate. Okay, it gives an A of 0. That's our rate of change. Our means our values didn't change, which doesn't surprise us because 12 never changed. It was always 12. Our B is 12. So if I sub in 0 for A, 0 times x would be 0, and the B would be 12. So I just don't put the 0x because you don't. 0 times x is 0, and 0 plus 12 is 12. All right, 0 property of multiplication and the identity property of addition. All right, so go back to stat, edit, and we're going to look at the last set of our data. Okay, so again, we're going to start with the highlighted row, 12, 14, 16, 18. 12, 14, 16, 18. Okay. 12, 18, 24, 30. Okay, so check over your data. Make sure you have it into L1 and L2. Then hit your stat, calc, linear regression, okay, so A is 3, our rate of change is 3, and our B is 24. So this says plus B, but remember if B comes out negative, we change that to a subtraction sign. So here's the answer up here, 3x minus 24. And this would be the answer to, this would be the piecewise function that would match up with that data. Okay, thank you very much for watching. Have a great day. And I'll see you tomorrow.